Listen-only mode.
Good afternoon, everybody, and welcome to today's special presentation, 1-hour lunchtime webinar. Today's topic is what T&Ers need to know about project management and systems engineering. Special presenters today is Dr. William D. Dave Bell and Dr. C. David Brown. For those of you that have not done a go-to meeting, go-to webinar before, a little primer on the control panel. You should be able to see the screen now. You have a control panel that you can use to adjust your reception as far as the audio, and also ask questions. There's a red arrow in it that you can use to click on to either hide the panel so that you can see the full screen, or extend the panel back out if you want to do some additional items. You can either use your telephone or your computer microphone and speakers to participate in the webinar today. If you use your telephone, it'll give you a dial-in number, an access code, and an audio pin. If you want to ask questions during the webinar, use the chat box, type in your questions, and Dr. Dave and Dave will get to your questions either during the presentation if they can, or at the end of the webinar. You also have some time at the end of the webinar to ask additional questions. We'll utilize the chat box because we have so many participants. It can get confusing from time, so we'll utilize the chat box. Also, if you have some questions that come up later, feel free to email either of our presenters or email me directly. This is James Gadry, and we'll make sure and respond to your questions. If you want to click on auto hide the control panel, just open up the view and then click auto hide, and it'll automatically hide the panel so you can see the full presentation. Upcoming professional development opportunities. We got some short courses coming up this month. Cybersecurity Information Assurance is next week, Tuesday, Wednesday, in Crystal City, Virginia. And in this, the course that this webinar is kind of providing an intro to, what T&Ers need to know about PM and SE, will be conducted June 18th through the 20th. That's a 3-day course. Also in Crystal City, Virginia. The early bird rate for that course has been extended to June 10th. So you do have through next Monday to register for the course and get the early bird rate. Workshops coming up. We have the Systems of Systems and NIE Experience, and the R&D use of propulsion vehicles. They're being co-located this year. Both will take place July 16th through the 18th in El Paso. And the early bird registration on that runs through June 17th. So sign up early for those workshops. One fee gets you into both workshops, all the sessions, general sessions, and the exhibit hall. The Certified Testing Evaluation Professional Examination Schedule. We got one a month here in Fairfax at the IT Executive Office. We'll also be doing one in El Paso in conjunction with the Systems of Systems and the propulsion workshops on July 19th. We have one scheduled in October in Las Vegas, and other sites will be scheduled to make sure that that exam is available out in San Diego, Fort Huachuca, Rocket City, and other locations. So check the ITEA website, www.itea.org/certification for more information, to apply, and also to check the schedule. So without further ado, please welcome today's presenters, Dr. Dave Bell and Dr. Dave Brown, and hope you enjoy the webinar. Dr. Brown?
Actually, this is Dave Bell.
Okay, Dr. Bell, I'm sorry.
I want to make sure that's fine. I want to make sure you're seeing the slides. Are they coming through?
Let's see. There they are. All right, I
Okay.
see him. We got him now.
Okay. Very good. I wanted to thank IT and James for allowing us to do this today. The other Dave and I have probably over 80 years of experience in test and evaluation world, and one of the things we discovered years ago is that we didn't live alone, but in the systems engineering and program management environment as well, and yet there were a lot of things we didn't know about those topics, and so we decided it might be useful based on our experience to share that with others. So that was the basis for this course. That didn't work. What did I do wrong? All right. Should just be left click, right? Okay. All right. So this little webinar we're doing today is from a 3-day course that we're hoping that you will want to join us in. And we're going to already talk about three or four pieces of that course in the next 40 minutes or so, providing an overview of PM and system engineering. But you can see, and also about DT versus OT and about the acquisition process. But you can see there are a number of other topics about the interaction of PM and SC involving simulation, current trends, some case studies, and special topics. So if you're able to come to the whole course, those are the kinds of things that you'll hear a lot about. So this is me. I'm Dave Bell, and I work for the MITRE Corporation, retired civil servant, worked for the federal government for a long time, and I work in mostly test and evaluation, both developmental and operational, though I also spent a lot of time in system engineering from beginning to the end, starting with requirements definition. And on the side, also do some lecturing for the Southern Methodist University at Johns Hopkins University. So that tells you a little bit about me, and now I'll turn it over for a little while to Dave.
Okay, and I'm Dave Brown, and just a little bit about me. Colonel in the Army, retired from the Army, also a Department of the Army civilian, grew up in the developmental test world, out on the test range, and then to the headquarters, then actually moved to work in a PM shop as the chief tester for the Army Future Combat Systems program, then retired from civil service, and now serving as a consultant to the MITRE Corporation, and also teaching systems engineering for Johns Hopkins University. Just to give you a little bit of an introduction to the course up front, as James said, we're going to talk about program management. Well, of course, with program management, the program manager and the program needs information. It needs information for the to inform the stakeholders, to understand risk, and to assure that that all of the program management processes are working as they need to. And this information comes in a large part from test and evaluation. So obviously the testers and evaluators perform a key role in the project management process. Also, the test and evaluation itself is a sub-program that involves schedule, involves resources, and involves work. So testers and evaluators need to understand the program management process so that they can properly merge test and evaluation into the overall program management. A lot of the same goes for systems engineering, because systems engineering is very much a part of the acquisition and a vital process in the overall development program. But systems engineering also needs a lot of information to feed all of these processes, sub-processes to systems engineering that are listed on this slide. And likewise, this information, in a large part, also comes from test and evaluation. Also, the test system is a system that in itself must be systems engineered. So in a large part, testers also need to be systems engineers, certainly need to understand the sub-processes of systems engineering. And and also a good understanding of systems engineering allows testers to bring the technical discipline of program development and systems engineering into test and evaluation. Just the steps for program management, and many of the stakeholders that need test and evaluation info need to be provided information that they can use, that they can understand, that is in the correct context for those stakeholders. And so because that information comes from the testers and the evaluators, the testers and evaluators must understand these perspectives, understand the processes that are generating this information and how the information is going to be used. So all of that gives you a feeling for the why, and with that, I'm going to turn the control back over to Dave Bell.
Okay, I saw a comment that said that I sounded a bit muffled, so I made a few adjustments. I hope perhaps it's better. Please advise. So the situation we find ourselves in, to state what's very obvious, are a lot of challenges in the current world. Some are listed here: the terrorism, various culture clashes, information overload, technology complexity, etc. And it seems like the world's looking to engineering and technology to try to resolve these. I'm glad to see I'm sounding better, thank you. I'm trying to resolve these issues. And so the problem attributes are technical, they're huge, they're complex, high importance, and they can involve social, political, and fiscal aspects. All of this needs to be and can be worked through the process of system engineering and needs to be managed. And so, as we're going to show in a moment, to show the relationship in the T&E to working with system engineering and management. See, I clicked on that and it didn't. Okay. All right. So the system engineering approach, which gets described in a number of ways, this is just one way of looking at it. Starting from a need, they're sort of just a little left center there of this circle, and some need, a critical need, maybe from one of those problems that we talked about in a previous slide. And so then we can develop using technology to determine whether it's possible perhaps to solve those needs, to work on those needs. We can put together some concepts that might be the answer, and then we go out and see if in fact does it solve the problem. And then so we think it will, we've got validated the solution, then we can build something that we can it can be implemented in the field, whether military or otherwise. And of course, test and evaluation is a part of the process in many of those steps, and particularly as we get a little bit farther along in there. So here's how we like to depict the relationship between all these things. There's some of the standard system engineering things on the left, and standard project management things on the right, and some of the things that sort of cross both fields, like the CM and quality control and contract management, etc. Well, so what does T&E have to do with these things? Well, T&E is a process that can get the information to provide to the various decision makers, whether they're a systems engineering type of decision or a project management type of decision, particularly of a technical nature. So we feel that the T&E role is very important to both of these major players in developing new systems that can solve problems. So John McCain, Senator McCain, had these things to say not too many years ago. He says that the military industrial complex does not cause problems, but cause programs to fail. But oftentimes they're poorly conceived and they're so fundamentally unsound they're doomed to be poorly executed. And when he says poorly conceived, he meant insufficiently defined requirements, unrealistic cost or schedule estimates, immature technology, too much manufacturing integration risk, and unrealistic performance expectations. One of this is that, from our perspective, is that people involved in T&E can help to improve this process, like the requirements definition process, and can provide information about the status of the systems as they go through their process of development, engineering and development. Okay. And over to you.
Okay.
Yeah.
Hopefully. I did not. Okay, I'm sorry. I found out that I didn't unmute. So I'll back up and say that hopefully you all had the opportunity to read the guest editorial by Mr. Kendall that appeared in the March issue of the ITEA Journal. Mr. Kendall emphasizes over and over again how important testing is to providing information. He does indeed have a sign outside of his office that says, "In God we trust, all others must bring data," and that data indeed does come from test and evaluation. He emphasizes the point that programs need relevant information as early as possible. Again, comes from test and evaluation. He closes his editorial saying that testers provide the information that makes program success possible and much more probable. What that tells me is that programs will not be successful without good test and evaluation. That's essentially what we say here. We've taken some excerpts out of the Defense Acquisition University's Test and Evaluation Management Guide. And again, this says that not only does a program need to have good test and evaluation, but it has to be integrated, well integrated with systems engineering and program management, again, to assure program success. So I think that with this quick introduction, we've hopefully made the point of why testers and evaluators need to understand the processes of systems engineering and program management. We've given you a first look at some of the things in systems engineering and program management that that testers need to understand. So let's take a little bit more of a look at systems engineering. We're going to hit the highlights of systems engineering, starting out with essentially a look at a system. And important things here on this slide is is a system is generally incorporates a lot of different capabilities, certainly true of our DoD systems, generally multiple elements, and it has a definable structure and interconnections, and it's bounded. You can put a boundary out around it, and you can define inputs and outputs that go through that boundary into and out of the system. Generally, a system can be broken up into pieces. So usually we partition a system into subsystems. Those subsystems then partition into components, and we keep going down. And generally in the engineering process, we generally get all the way down to a low level where we can begin the development, and then we develop that and we integrate those pieces back together and eventually end up with the whole system. And we have different ways of looking at it. There is the overall systems view. Now, harken back to that slide that Dave showed you of systems management that has the overall systems view, and within that we have the systems engineering, which is the technical view of it, and then we have the management part, which is the management of the process. We're going to talk to those things under when we get to program management. Key issues that for a long time test and evaluation has been perceived as very separate from systems engineering and program management. We actually have two very separate communities here, where we would have a program management community, a systems engineering community, a test and evaluation community, and we perceive that that there is a real lack of understanding among those communities. And so a purpose here of this webinar and then the short course is to help with some mutual understanding so that those communities can certainly operate together much better, because, as we've already said, test and evaluation provides the information that they're needed, and also the test setup, it does need to be systems engineered, and the T&E program must be program management. So very simply, those are the basic connections.
Okay, so what is a system? I think a lot of us have an intuitive feel for what a system is, as though there doesn't seem to be a universal one definition for everything. Here are three definitions. And certainly almost everybody would agree they're interrelated components working together toward a common objective, and generally speaking, very synergistically. And it can certainly be, those components could be hardware, software, and people, and data, and services, and all these kinds of things to perform a certain function or collection of functions. Generally, it'll be a bounded process with specific interactions among a number of separately distinguishable functional elements. So there's a lot of ways of looking at it, and but I think we tend to have a sense of what a system is. And they vary in scope. To some extent, one person's system is another person's subsystem, depending where you are in life and what you're doing. And here's a collection of things, and it gets more complex as you get more things working together, from all the way from a device and component subsystems like this infrared seeker to a missile, to the whole Aegis and right on up to theater defense. So it depends where you are in this chain of things, what you might be referring to as a system. But I think you get the idea. Let's see. So what is in a system? I like to make the point here that it's not just the operating equipment, which is sort of the headliner and the poster child that's in most people's minds, but in fact, it's all these things that without any one of them, you don't have a system. It will not function as it's supposed to. including the maintenance personnel and facilities and transportation and handling and spares and the maintenance data, all those kinds of things which aren't necessarily in the front of one's mind when they're thinking about a system, yet they're absolutely essential. So we like to remind people that all these things are included in a system. What's the environment that currently systems have to exist in? Well, one of the banes of testers and for that matter program managers is the requirements are oftentimes changing quicker than we can make adjustments to try to match the requirements. These days there's a lot more emphasis on the systems rather than the components, yet the systems will fail otherwise if they don't have all those components, et cetera. Another big deal these days, which is relatively new in my lifetime, is the dependence on COTS off the shelf. The globalization and the fact that there's both international competition and less competition internal and domestically. So few companies that can provide the various things that go into a system. What is system engineering? Well, it's the process of doing these things. It's interdisciplinary, and it features a lot of things in addition to a normal type of engineering and design, but it includes people who are knowledgeable in environmental and economic and political and other things that are not mainline necessarily engineering things, but they have to be considered in the creation of these systems. And the note down there, the customer usually states the initial version of the requirements, but they necessarily need to be better defined and refined as time goes on, and often the requirements do change. What are some identifying qualities? Well, try to be top down, look at the system as a whole from the beginning, and then break it into pieces. A life cycle view, not just the initial acquisition. A complete, in same quote because it never can be, but try to identify the system requirements up front completely, and necessarily to do it well, it needs to be an interdisciplinary team. Now, the scientific method is an approach to discovering knowledge, and we're all one that we're all familiar with. For what Dave and I have noticed, that the system engineering process, and I guess it wasn't just us, this fellow here that we refer to, is a very similar process where we start with the requirements analysis and a functional definition and then some kind of physical definition, and you create something, and then you see, well, does it do what you wanted it to do? And then there's feedback all along the way. Very analogous to the system, to the scientific method. System engineering approaches, well, there are a number of them. The most common of which, and we'll talk even more about it after a while, is the system engineering V. But in general, it's something that starts with the requirements and gets decomposed to something that can be built, and then you put those pieces together and you end up with something that you can use to solve the problem. And whether it's spiral, waterfall, or V, you tend to be going through those kinds of processes. There are more details in all of these, but I'm not going to go into them right now. One of the things I think is important as a tester to note, because sometimes we tend to think we just shows up toward the end when the system's there and test that, but that's really a very bad misconception. And here across the top is some of the typical phases of the system engineering process, and you can see that there's a role for, as we have indicated in the bottom there, for test and evaluation, participation, all the way through, and not just at the far right, even though I don't want to minimize that. It's not, my point is that there is a role for T&E from beginning to end. Why is there a motivation for better system management, which we see over and over in these days? You may or may not be aware of it, but as you're going through the design process, as this depicts the major phases, you will necessarily discover the need to make design changes. And the later you discover them, the more expensive they are to make those changes. And so if we can do a better job of system engineering and system management and find the changes that need to be made earlier, it's much less a costly process. The role of systems engineer, the technical leader and conductor of all the activities of both the design engineers and the specialty engineers, and providing information to management at various levels, establish the plan, oversees the execution, enforces the requirements, which also can mean judging whether a requirement has to be changed, and being willing and able to make adjustments to all the planning documents as necessary, a major advisor to the program manager, and ultimately is the responsible person for the technical product.
I need to include a quick word about system of systems, because in the DoD, most systems operate in a system of system context, where they combine to deliver a broad capability, and they generally interconnect via a system of systems architecture, which facilitates this this interaction of the systems. Now, one mention here of a family of systems, because that often is confused with sister systems, and the family of systems is a much looser coupling, and in fact the systems don't necessarily interact to deliver a capability. Often they just maybe share common components. In the case of like the Stryker family of systems, they shared common chassis and engine and things like that, but didn't necessarily function together as a system of systems. Now, a system of systems must be engineered, and it is a systems engineering process. However, traditional systems engineering that Dave Bell just described, you're dealing with well-bounded systems and firmly established requirements, whereas and it's and as I talked about, integration of the parts to form components, components to form subsystems, subsystems to form systems. So in that respect, it's a little similar to system of systems. However, systems of systems generally remain very flexible and changeable with time. And again, we're focused on the capability that it delivers and constantly changing relationships among the systems. So we focused on the architecture, we focused on interoperability and integratability with system of systems engineering. So because of that, it ends up being much more difficult to test a system of systems. And in fact, there is one significant test challenge, and that is to be able to quantify and qualify the individual systems' contributions to the system of systems. Although the similar systems engineering practices apply, integrate and test, we're back up to this contribution, individual contributions to the system of systems, and that is a challenge that we're seeing within the DoD, and we have some examples in the course of how the various services are working on that. So at this point, that's been a really quick coverage of systems engineering. So let's transition a bit now to program management, because systems engineering focuses on the development, whereas program management focuses on leadership and management, and focuses on generally cost, schedule, and performance. These are the three dimensions of the management and leadership of the program. And so it is a program or a project or a task. One person's program might be another person's project. They all can look the same depending upon your perspective, but it generally is an activity that is unique and needs resources and is accomplished by an organization, and as I said, involves cost, schedule, and performance. So a program involves project planning or program planning and control, and it's a continuous process of planning and control. Dave mentioned that within systems engineering, that involves planning and it involves changing the plan or adjusting the plan. Well, the same thing goes for the project plan or the program plan. So it is a continuous process of planning, controlling, monitoring, and deciding how the plan and the process needs to be changed. There are three elements of the planning and control that align perfectly with those three aspects of the project: cost, schedule, and performance. Well, the planning and control of the cost aspect is accomplished by the budget. Of course, the schedule is the planning and control for the schedule part of the process, and then the performance part of the process, we have a planning and control mechanism known as work breakdown structure that we go into much more detail when we get into the 3-day course. Dave mentioned the systems engineering V as the one of the views of the systems engineering, and so from a program level, essentially the customer delivers requirements to the program and the program manager oversees the accomplishment of the entire program, which takes in the customer's requirements and then assures that the customer gets the output of this systems engineering V, or the stuff that the customer needs and desires. Within that process, the systems engineer guides the understanding of the requirements, the development of the system, and then test and evaluation gives the information to make sure that it does indeed happen this way. Now, this is a somewhat simple view of the process, and quite honestly the way it happens a lot in the commercial marketplace, because the customer is developing the requirements, the customer gets the stuff, and the customer pays for it. So, but it's not quite that simple in the DoD. Things get changed a little bit because DoD acquisition actually has two customers, so life is a little more difficult. There's the warfighter user that theoretically develops the requirements and gets the stuff. So the requirements come from the user. However, that's the performance part of it. Now the cost and schedule, the process is not accountable to the customer. The warfighter doesn't write us the check, Congress does. So we have to deal with another customer in the process, and that makes things a little more complicated. A quick review of how the military works so that we can understand those dual customers there, and that is that, of course, it's the commanders, the warfighters are under the commander-in-chief, so it's that commander-in-chief or the White House that essentially uses the stuff and deploys the stuff. However, and it's not necessarily the chiefs of staff for the services. The chiefs of staff are not the deployers, not the users, but they have the responsibility to staff, equip, and train. So you see this equip part of the mission. So because of that, the chiefs of staff are the ones that generally develop the requirements, and then they hand it over from the staff side to the Secretariat side, and it's the Secretary of Defense that actually has the responsibility to develop, build, or buy the equipment. Now, can't do that with a little bit of help, and part of the help is the money to develop, build, buy. That comes from Congress, and Congress always attaches strings to money, and that's in the form of some laws and regulations and guidance that come from Congress that help the chief, or help the Secretary of Defense and the Secretaries of the Services accomplish this develop, build, and buy. So the systems engineering V gets changed a little bit. Requirements come in from the chiefs. Congress has a lot to say with that, also provides the money. Here's the Secretariat side actually doing the development, and Congress gets involved again with operational tests, and then eventually it gets out to the deployment side of the house. So the systems engineering be complicated. A lot of stakeholders in here. We bring in the military industrial complex, and this poor PM here now has many stakeholders to answer to. Here are those rules and laws that I was telling you about that govern the process. This is Title 10 of the U.S. Code, which tells the armed forces how they're going to do business, and there are specifics in Title 10 about some of the testing that we have to do. So operational test specifically appears in Title 10, so does live fire test and evaluation. We also have the federal acquisition regulations. Of course, we are contracting and we're buying stuff in the acquisition process, so we come under the FAR. And then the DoD 5000 is in the center there telling us how to do our job. That's the instruction on how we do the job. I told you that Congress always sends money with strings attached, and in our case the strings that are attached are generally the Defense Authorization Acts. So many of the authorization acts that give us money each year come with strings attached. Some of the most notorious strings were the Nunn-McCurdy Amendment, which essentially helps curtail and control cost growth and schedule growth. Developmental test and evaluation was one of those strings. With IT, we've got Klinger-Cohen, and the latest one is in 2009, the Weapons Systems Acquisition Reform Act, affectionately known as WSARA, and we'll mention that a little later. We focus a lot on the Defense Acquisition System, which is essentially that instruction DoD 5000, but a couple of other very important processes. Capabilities Integration and Development System is where the requirements come from, so that's where acquisition starts. And then we can't do it without money and schedule, so program planning, program, and budget execution, PPBE process is where we essentially get the cost and schedule elements. So things get a little complicated in the DoD. The user may articulate the requirements, or at least the needs, and then we've got the JSIDS process with the requirements. We have the contractors in there. We've got PPBE. We've got all of the oversight and the rules and the laws, and eventually out of this process, somehow the user gets the stuff. In 1971, it was a fairly simple process. We spent a little bit of time on the concept, then we spent a little time on development, and then we got it out there. It's gotten a little more complicated now. Here's the latest diagram of the management process that's in the DoD Instruction 5002. More phases, more decision points, still the basic sort of process. I love to show this slide. The Defense Acquisition University has put the entire process on a single chart. It certainly looks a bit daunting here. I guess the good news is that it still fits on a single chart. The other thing is notice that within the phases you see things that look an awful like the Systems Engineering V. So it is a process that does work. A lot of people think it costs too much and takes too long, but maybe it's because of all these blocks. Something that's important to note is that within this process, DoD acquisition is focused almost completely on materiel. However, there is an entire solution for capabilities. We call it LPF, Doctrine, Organization, Training, and down here I put resources. It's actually facilities and .mlpf, but facilities translate to resources in our thinking. But the bottom line is that often a capability can be delivered by developments within all of these. It's just that materiel gets all of the attention because that's where the big dollars are. That's what industry's involved in. That's what politics are involved in. So unfortunately, we get undue focus on materiel, and some of the others get ignored a little bit. We'll talk a little bit more about that in the 3-day course. Back over to Dave Bell.
So here's an ideal of what the system engineering view looks like, and with you starting the requirements and then to do the design and you implement that design, and since you've broken it into a bunch of pieces, now you have to integrate it, you test it as you're putting it together, and ultimately you have a full system. And the verification is, we're going to talk a little bit about V&V, the verification validation. Verification is verifying that the design gets implemented as in reality as the engineers designed it. The validation has to do with are there the right requirements, or does the full system meet those requirements? We are experiencing network connection to improve audio performance. Please close in. Okay, what does it say? You're getting a little choppy. Are you muted?
I am muted.
Okay. How are we doing sounding now? Can you hear me now?
Yes.
Okay. All right. So anyhow, that's the ideal. Now, the reality is that the time happens, that you don't immediately go from requirements to having a full system to test. And things happen during that time period, both in terms of potentially requirements changing, the threat changing, the mission changing, the technology changing. Things change. That's what happens with time. So so you end up you're verifying against a design that was created perhaps years earlier, and you're validating against the requirements that were created years earlier. So this is a serious problem, and we don't necessarily have the solution to that, but we wanted to recognize it. Ideally, you would be allowed to change your design and your requirements over time so that they're always current, and therefore the testing you're doing are against current requirements and specifications. But anyhow, this is the challenge that we live in. And so what does that mean to the program managers and to others? Well, DT, developmental testing, is focused mostly around verification, and its main player for deciding to accept items from contractors, but also, it has to do with the integration process, how we doing on that, et cetera. But the OT is where the requirements met. And oh, by the way, are they still the right requirements? Well, the first part of that question, PMs, I think, are okay with. That's what they expect to have asked. But are they still the right requirements is a challenge for PMs, because maybe they aren't still the right requirements, but their formal requirement document never got changed. So this is a source of a fair amount of contention between some testers and program management community. So this fellow, who's no longer in this position, is Dave Castellano. He came out with this a few years ago, and I think it makes a point that pretty much the statistics, to the most recent ones I've seen, haven't gotten any better. 33% cost growth due to RDT&E mistakes, and about half were deemed not suitable or partially not suitable, and a third not effective or partially not effective. This is the suitability and effectiveness are what's determined during IOT&E. And why weren't they suitable or effective? Well, there's lots of reasons, but a strong component of that was, in fact, the reliability. And as you know, there is a renewed interest in the last few years on reliability, and hopefully this will turn around. But it's been a serious problem and a serious element of that problem. So here's some more from Dave Castellano. What we don't, he claims, and I think he's right, we don't start them right with insufficient requirements analysis and definition, and we have unrealistic expectation. Oftentimes there's a lack of rigorous system engineering. The schedule is very success oriented, a lot of concurrency, which several things have to happen simultaneously and work together when they're both done. Poor estimation and planning, both cost and schedule. Test planning is often inadequate, and resources aren't properly planned. There's a lot of optimism that the reliability is going to grow, but yet not given the priority it needs, and in fact it doesn't happen. So these are some of the things that happen from the beginning. And as the note says, these areas that we've highlighted in red are areas that we think testers can be particularly helpful. And the management of them, the traits based on resources, schedule, performance, and requirements, and the risk management, of which it tends to be too little and too late. Quantifiable interest and exit criteria, maturing in the reliability, availability, maintainability, all this suitability type factors. The maturing effectiveness is not always a priority. Concurrent test programs, which when you find a problem, then you're in serious trouble because of the concurrency. And the operational test readiness review process, without a strong developmental test gate to give assurance that likely to be successful in IoT&E. Again, poor communication across government and industry. So testers like to say that PMs try to avoid us as long as possible, and there's probably, particularly historically, a lot of truth to that. I would add editorially that I think that situation is improving. But why do they do that? Well, testers are perceived as adding cost and schedule expenses at a time period when they were already under this kind of stress. So there's a cynic view, and maybe I don't know if that's fair or not. That maybe they didn't want to ask the question, they couldn't stand the answer. And there's also this optimism that we'll make up a lot of time to fix all the problems later, which is it doesn't turn out that way well at all. And by foregoing all these TD insights, then the current program manager may escape before the problems get discovered. So we're pushing for a change in attitude amongst testers and program managers to avoid this.
Well, in closing, a couple of slides here. First, I can't make the point enough that the Congress is one of acquisition's biggest stakeholders, and it is where the money comes from, and they do indeed try to keep the voice of the user forefront as well. The Congress cares about cost, and politically they care about who the contractor is and who's building it, but they also care about effectiveness, suitability, and survivability. So remember those strings that I talked about that come with our money, and I told you that operational test was one of them. Well, indeed, in Title 10, our law that governs the U.S. military, operational test is indeed inserted in there by Congress, and here essentially is the process and some of the issues with it. But a big issue is that often stuff wasn't ready for operational test when it got there. Congress knew this as well, so I said, well, we can't wait until the end of the process to conduct tests, so we need to put some more emphasis on developmental test and evaluation integrated with systems engineering. So I told you we'd say a little bit more about the Weapons Systems Acquisition Reform Act 2009. It created a Deputy Assistant Secretary of Defense for Systems Engineering and one for developmental test and evaluation, essentially to make sure that there was more emphasis on early test and evaluation and more emphasis on better integration between test and evaluation and systems engineering. Final word, system of systems, is we talked about that a few slides ago, and although that's the way most of the military gets used, it's not the way much of it is tested. So there is a emphasis now on system of systems test and evaluation, and in our course we have some examples of what the Army is doing anyway, and some of the other services to actually assure that we develop and test equipment in a system of systems engineering context. So just a brief look at the future. Things are changing. I showed you why pure systems engineering doesn't work for the DoD because of the different customers and all those various stakeholders. Congress is aware of all this, and so there are several hybrids out there. Lately we have been involved in conflicts where the COCOMs have driven rapid acquisition. Works okay for rapid response to immediate requirements, but keep in mind that it's not the way the acquisition system needs to work, because we need to be focused on tomorrow's needs, not today's. So the bottom line is that in the future we're going to see some budget cutting, so we're going to see fewer new systems. We're going to see a more push for discipline and rigor in the process. We're going to see more push for better informed acquisition, which involves better T&E and better understanding by the testers and evaluators of their true customers, which are the program managers and the systems engineers. And so overall this needs to result and will result in better systems engineering, which will, as Mr. Kendall said,
So, see that you lost Dave's audio. I don't know exactly where you were or he was when that happened. But anyhow, if there are some questions that someone would like to ask, we can read them, and then we'll respond. If not, then I guess we turn it back over to James. James, if you're talking, we don't.
Okay. All right. Thank you very much, Dr. Brown. And Dr. Brown, excellent presentation. We do have a few minutes here that if anybody has any questions, type them in your chat box or in your question box. There's a couple of questions. Basically, are the slides available for download? And, you know, we are recording this webinar, and the webinar will be posted on the ITEA website. Actually, if you go to, I'll show you where it is here. If you go to on the ITEA website, www.itea.org, and if you go under Learn tab there to Professional Development, and then navigate to On-Demand Webinars and Presentations. We have quite a few webinars there and presentations from the various workshops and conferences that are available, and I'm not logged in, so I can't get to it right now, but that's how you would get to it. This recorded webinar will be posted up there within a couple of days, so you will be able to view it there, as well as share the link with other people. The slides, are you going to provide, do you want to post your slides up there as well? I guess that's an option for the presenters if they want to post their slides. Dr. Brown, Dr. Brown.
Yeah, it wasn't solved.
Okay.
James, we're saying yes. I don't know if you can hear us.
Oh, okay. Now I can. Okay, so we'll have the slides posted up there as well. And copyrighted, yes, they are copyrighted, so you can't, copy them and use them for your own purposes. You would have to contact, Dr. Dave Bell and Dr. Dave Brown if you want to use them for other purposes, and they would have to give you permission to use them. Let's see. There is a question, how is the current budget cut going to affect the way that we do testing? If either of you would like to respond to that question. We can't hear you.
Okay, that's Dave Bell. Can you hear me?
Yes, sir.
Okay. But Dave was trying to respond, but for some reason his microphone's not working right now. So I'm not sure what he was going to say, but what I would say is that, as in many disciplines, it's going to require us to be much more sensitive to cost. But on the other hand, I think it'll mean the value of our information that we provide as test evaluators will be even higher than ever to help make the decisions about both program continuation or changes in a timely fashion, so that cost can be avoided. So I also think another implication will be earlier involvement of T&E to help get the information sooner to make decisions when the decisions are less expensive.
Okay. All right, very good. All right, well, I think we went a little bit over, but I appreciate everybody's time. Dr. Bell and Dr. Brown, thank you so much for taking time out of your busy schedule to provide this webinar. Very informative. And just a reminder, we do have a short course coming up on this topic, June 18 through 20. It'll be in Crystal City. The early bird registration rate's been extended to June 10th, so through next Monday you have the opportunity to register at the early bird rate. We also have a cybersecurity information assurance course going next week. And then we have an operational DOE course in Tempe, Arizona at the end of July. And then our conference, our workshop coming up, 2 workshops co-located in El Paso, July 16th through 18th, System of Systems and NIE Experience, and the R&D use of propulsion vehicles. And if you want to get certified, please visit the ITEA website /certification for more information and to apply. Thank you so much for your participation today. Once again, the slides in the presentation recorded webinar will be posted on the ITEA website within a few days. We appreciate your support of the association and your commitment to professional excellence. Please let us know what else we can be doing to assist your success. Thank you very much, and we'll see you very soon. Thanks, guys.
You're welcome.